All right, so today we're going to be restoring this absolutely massive 170-pound Prentice 22 swivel jaw, swivel base vise. Now you see that little pin on the back there that I'm grabbing with the wrench. That is the swivel lock pin. Now I've restored other swivel jaw vices before, but if you've never seen one of these, if you were to remove that pin, that rear jaw would actually be able to pivot so that you could grab uneven and non-parallel sides of an object. These are really awesome to have, and the Prentice 22 is one of the larger vices that were ever made in the early 1900s that has this swivel jaw design. Now, disassembling this vise is pretty easy. Take the dynamic jaw out, which is the movable jaw, and remove the base, and then I can remove the screw box and pull off this little pivot lock, which is a spring-loaded pivot lock. Now, I love a swivel jaw vise, and this one, while it does need a bunch of work, I think is well worth fixing up. But if I can't get that pin out of the swivel jaw, then this is just a regular 6-inch vise, which I already have a few of, so getting this pin out is super important. Now, it's clearly seized in there. I've tried a couple ways to get it out, and what I'm going to use in order to actually free it up, some WD-40 Specialist Penetrant with Easy Reach. This is going to be able to sneak into those little crevices and help free up this seized piece of metal. Now, this is a tapered pin inside a tapered hole. It has extremely high surface area contact, so it's going to be very difficult to get this out. I turn the vise upside down and I spray some of that Specialist penetrant spray inside the hole, and I let it sit overnight, and I do this actually for a couple of days. Spray the WD-40 Specialist penetrant spray in there, let it sit and soak, and then continue to work on it with a mallet and a wrench. And finally, after realizing that I wasn't going to be able to get it out with the small leverage point that I had, I decided to take this old scissor jack and cut the feet off of it so I could wedge it inside the vise body and use that to try to remove this pin.
All right, a quick break to talk about a contest that's being run by this video sponsor, which is WD-40 brand. For the second year in a row, the Repair It, Don't Replace It contest is back, where you can win up to $5,000 by taking an old tired item from your home, garage, basement, yard, and fixing it up just the same way that I'm fixing up this 100-year-old vise here in my shop. It's super easy to enter. You go to repair.wd40.com, and there's some rules and instructions there, and this contest runs to July 14th, 2024. So grab something, fix it up, enter on the website for your chance to win $5 grand. There's also a bunch of prizes that go down to, I think, like 29th place. So your chances of winning are pretty good. So anyway, thank you to WD-40 brand for sponsoring this video and giving all of you the opportunity to win some money, doing something just like this, and let's get back to the video.
Now, this is obviously a ton of effort early on in this restoration, but if I can't get this pin out, this is really all for nothing. So I had this scissor jack that I had used on another project, and I thought it was worth cutting it up just to make this little jig so that I could try to pop the pin out. So what I did was I made a little short pin out of 3/4-inch bar stock that would fit inside the tapered hole. I rigged it in there with a pair of pliers so I could get it set in the perfect location, and then tightened up the scissor jack to start lifting things. I also took a socket that was a close size to the pin, and I hammered it onto the pin so that I could use a large impact wrench to try to get it to break free. I cannot believe how much force this pin took to finally remove, but after kind of soaking it with the penetrating spray, using the scissor jack, using the impact wrench, you can see I'm actually like starting to stretch the whole frame of the vise using this little scissor jack and starting to break it. Finally, after a couple of days, it broke off. You can see the amount of tension that got relieved from the vise. I was super excited to have this part done, and now I can continue on with the restoration.
I got it!
I needed some more penetrant spray to actually get the swivel jaw freed up, and some persuasion with a mallet. And you can see the design there. You've got a pivot point on the front and then sort of a track on the rear that the whole thing moves in. Now, this large of a vise, obviously all the components are really big, but I still want them to move really freely. I don't want this to be a sluggish and slow vise, so I want to make sure I clean all the gunk and grime out of it and try to get the 100 years of corrosion and filth out of it. Now, the other thing you'll notice about this vise is one of the feet on the base is broken, and don't worry, later on in the video, we're going to do a pretty complicated nickel brazing job to try to fix that up so that we can get this thing perfectly restored. Now, when I'm using a swivel jaw vise, it's typically on something a little more delicate, and honestly, most of the stuff that I work on is stuff that I don't want to get marked up. Now, these larger vices tended to have really heavily knurled jaws that had a lot of kind of grabbing force to them in those knurls, but the problem with that is that it always will mark up whatever you grab with it. So even still, these jaws are pretty shot, and I want to knock them off and then remake them to be soft jaws made out of brass with a couple of unique features that I'll cut into them over on the mill a little bit later in the video. Getting these off, I did try to take the screws out, but that was kind of a wasted effort, so I wound up just drilling off the heads and knocking the existing jaw off with a chisel, and then I could grab what was left of the screws and actually screw them out. I was surprised the screws came out considering how chewed up everything is on this. I figured they would be kind of seized in there, but the threads were still good. The screws popped right out, and then that little centering pin can just be pulled out, and I can keep moving. Now, there was a little bit of swivel action that I could get on the base when I started. It was moving a little bit, but clearly it needs to be cleaned off. And I also want to remove the screw inside the dynamic jaw, and the only way to do that is to actually cut this sort of locking collar that looked like it was peened in place on that jaw itself. Don't worry, we're going to do a thrust bearing setup and really make the action of this vise incredibly smooth, as though it was just brand new and, you know, made this year a little later on in the video with some bearings and a different shaft collar. So luckily the screw is in good shape, but I do want to cut the handle off and remake that as well. And I'm going to be adding a silicon bronze sleeve to what we call the meatball end, that end of the screw, later on in the video. Again, just trying to make sure that this thing is cleaned up as best I can get it before I move forward. And while I sort of wait for some material to come in, I had ordered some silicon bronze and some brass for the jaws. So while I waited for that, I could get rid of the gunk and grime. And I'm using a WD-40 Specialist degreaser that is inside these little easy pods. I've shown these in videos before. You just drop them into a spray bottle and then you can make degreaser basically in any volume you want. I made up this little extendo reach wire brush after I sprayed the degreaser inside the dynamic jaw to try to clear out that gunk. And if you ever need to clean out a vise like this, just buy a cheap wooden brush, glue a stick to it, and then you can get nice and deep in there. The other thing I need to make sure I do is clean out the insides of these little holes. Now, these are actually how you do the pivot lock on this vise. It's kind of unique, as most vices have a screw that you would screw down tight. But these, you actually have this little spring-loaded pin, so you can lock it into predetermined locations, kind of indexing it along the way. Continuing to clean it up with the wire brush, just doing the best I can by hand to get rid of the gunk so that I can go ahead and move on to the downdraft table and use an actual wire wheel on a grinder to remove the majority of the rust. I worked through this pretty quickly, but I did want to also clean off a lot of the weld spatter and a lot of the other sort of major blemishes on this piece. Now, I really like using a round wire wheel, but you can't normally get into tight corners. So if you've never used one of these, try to get yourself one of these single point wire wheels. This one is from Pferd Abrasives, and you can see how nice it is for getting into nooks and crannies. I have it on the end of this little die grinder, and it really just gets all the little things that a regular size wire wheel just can't pick up, and you can get into super tight areas, and it's a really useful thing to have. It's a single point wire wheel. I'll leave some links in the description on where you can get that and some other tools that I use in this project. Now, I don't want to completely get rid of every single blemish and scar on this, but I do want to get any of the spatter, the weld spatter off of it. I like the idea that this vise tells a story of 100 years of hard work and has some battle scars along the way. Now, the actual swivel jaw wasn't operating really well, so I actually went ahead and I took a die grinder and I ground out the track so that I could make sure that I had a really smooth action when I was actually using the swivel jaw. It was jamming up along the way, but by using the die grinder, I was able to make that track perfect. With that all done and the swivel jaw working perfectly, I used one of these Polifan curved discs from Pferd to just clean up the backside of the swivel jaw so that it would just look nice and smooth. But like I said, I did leave those sort of deep marks and blemishes just to show the history and the battle scars that this vise has had over its 100-year life. When I was done with that, I used one of these stripping and cleaning discs, the Polifan disc, to just smooth everything out nice, but again, leave a lot of those deep imperfections so that it would just be nice and smooth to the touch. Now time to get some work done over on the lathe. So the first thing I need to do is remake the swivel jaw pin, which is a tapered pin, and I damaged it pretty well when I hammered that socket onto it, but it's okay. It's pretty simple. It's about a 2-degree angle, so I just use the compound on my lathe to actually cut that angle in. First I had to dress this material. It's just some 1-inch bar, and then I use my compound and just sort of gently take in at that taper, cutting it in to make a pin that was the correct taper to fit inside the taper hole that was cast inside the vise. Now, the tool that I'm using is not that sharp. I have a feeling it had a chip in it, and my tool geometry wasn't great, so I didn't get a great surface finish, but I was able to go back afterwards and clean it up on the belt grinder and make it nice and smooth and polished so that it doesn't have any burrs that jam up its action. I do use a file to take down any of the major high spots, and then I grab a little single point kind of 45-degree tool and put a couple of knurls in it so that it's easier to grab. In the end, I feel like I made the pin a little bit too short, but it does work really well and it's nice and clean. The next thing to do on the lathe was to make the handle for this vise itself. Now the handle that was on there was pretty bent and it was just in bad shape, so I decided I would make one custom and I would fit it in a silicon bronze bushing so it would work really smoothly, and I would do threaded ball ends on it so I could take it out and add rubber washers or do anything I needed to do to it. Now, I needed a 7/8 inch rod, and unfortunately, I only had 1-inch bar, so I had to turn down an entire eighth across this 16-inch long piece, which wasn't so bad, but definitely took a little bit of time. I, again, didn't get a great surface finish, so I used my pipe polishing tool. I've made a video about this that I'll link below and above, and this was just a really great way to kind of clean up this spindle on the lathe and get it super, super smooth and really nice and easy to grab. With that done, I can cut it off, and then I put these brass soft jaws on my lathe so that I could grab the shaft that I just turned down and essentially polished and face off, drill, and tap the end to receive the threaded steel 1.25-inch balls that will be on the ends of this handle. Now, this is a pretty simple procedure. I just used a spotting drill and then chased up to the size hole so that I could drill a 1/2-inch 13 thread. And then I basically just took a bolt and used it as a stud to put these already threaded balls in the end. Here's a close-up look of that operation. So spot, drill out to the correct size, and then tap with a 1/2-inch tap. Then I used a large countersink to get a nice recess so the ball would sit nice and flush, using tap magic as I go. And then you can see the stud going into the actual handle, and then the ball threading on it. It's a really nice and clean fit. The next thing I have to do is actually bore out the meatball on the screw. And I have to bore this out because I'm going to be press fitting a silicon bronze bushing in there, and I need to have a little bit of room for that bushing to fit. Now, once again, I broke my tooling as I was going, and I got a pretty bad surface finish on this, but it's okay because that little extra bit of grit and sort of unevenness will actually probably make my bushing fit even better. So I bored this out, and then I grabbed my silicon bronze. This is oil light bronze. I keep calling it silicon bronze, but it's just an oil light lubricating bronze, and I drilled this out to 7/8, and then I parted it off after I faced it down a little bit so that I could go ahead and press it into the meatball using my arbor press. This stuff was kind of chippy when it turned. It didn't pull out nice shavings. It sort of like kind of shattered away, almost like turning cast iron. I never turned oil light bronze before, but it did come out pretty nice. Just checking all my measurements and making sure that I have a nice tight fit, and then I can grind off some of the burrs on this screw before I head over to the arbor press. Now, I didn't grind this completely flush because I wanted to leave myself room to do touch-ups and fix it later. And before I pressed in the oil light bronze bushing, I heated up the meatball, and then look how satisfying that is to press fit that sleeve in there, and then using the plate on my arbor press to just kind of push that in so it's even on both sides. But super satisfying to use the arbor press for this type of work when you get that nice, super tight pressure fit. This thing is literally never going anywhere. I probably couldn't get it out of that meatball if I tried. And then you can see the way the new handle shaft fits, and I'm really happy with how all that came out. Now the next task is to make myself some new jaws, and I'm taking some 1-inch thick by I think 2-inch brass. This was pretty expensive. I got it from onlinemetals.com, and making myself a brand new set of jaws that will act as kind of multifunctional soft jaws. Now I need to make 2 sets, so all the operations that you're seeing I'm going to have to do twice, but I start by milling the pocket so they fit on sort of the vise shelf on the jaw, and then I go ahead and face off the ends so they're nice and flat and smooth and even, so that I can use a stop to drill all my holes and machine in all my other fixtures. Now, some of you that watch my videos may know that I just got a beautiful ProtoTrack CNC machine and restored it, but I really don't have enough programming experience to use it on something like this, so I just went over to the old manual Bridgeport and got this done using the DRO. So I made sure to mark off and measure for all of my holes for my bolts, and then I took this 90-degree V-groove end mill, and I milled in a horizontal and vertical slot. And the horizontal slot and vertical slot are both dead center on the material, respect to their direction. And what these are for is for grabbing round stock. It's really useful when you can have any sort of V-jaw when you're trying to grab round material in a vise, and it'll keep it from slipping. So this is going to be a really useful thing to have, and I'm really happy that I made it into these jaws. Now, as hardware for this, I'm going to be using these little Allen head 3/8 inch screws, and I'm going to make sure that I countersink them nice and flush below the V-groove so that they don't interfere when I'm using a piece of bar and grabbing them in the vise. You'll also notice that I milled in a small shelf at the top of each of the jaws, and that's essentially to act as like a permanent parallel. So now if I want to grab a piece of plate to drill holes in it or work on it, I can grab it nice and high, and I don't have to worry about it falling down in the vise, and it'll allow me to work on it nice and flush with the top. I think that's going to be a really nice feature, and honestly, I wish all my vices had something like that. I do a little bit of deburring and just check my fitment, and overall these things came out beautiful, and they fit really well together and are going to work awesome once this vise is complete. The next task and mountain to climb is to re-weld this foot. Now, the base of this is 5/8 inch thick cast steel, and I'm missing an entire bolt foot. So I make a little template out of cardboard and try to figure out exactly what I need to do. And then I grab some 3/4 inch plate that I had left over from making a swivel base for one of my Wilton vices and chunk off a piece. Now, originally, I was going to do this using the 3/4 inch material, even though the material that I need is 5/8. I thought I'll just leave it thick and I'll grind it down. But after marking some things out and doing some prep work, I decided it would be best to go over to the Bridgeport and face it off, which I'll do in a second. I added a pretty heavy bevel to both sides of the broken foot so that I'd have a nice weldment that I can fill in with some solid nickel tech rod later on. Now here's about the point where I notice that my piece of material is way too thick after I start cutting some things up, and I take it over to the mill and I just do a pretty hefty facing pass on it so that I can try to make it thin enough so that it'll actually match and I won't have to do a ton of grinding. This was super easy, just used a shell mill that I had, and I took about 1/16 passes, so it only took about 3-4 passes to get the entire thing totally faced off, beautifully smooth, and then I could go back, bevel, and get it ready for welding. Now, welding cast iron is incredibly tricky. It is like welding sand. It falls apart on you, and there are air pockets and bubbles and impurities. And the best way that I found to do it is I use some Lincoln Electric Tech Rod 99, which is a solid nickel stick welding electrode, and I TIG weld it in after I remove the flux using a hammer. Now, in order to keep the cast iron from cracking, you need to keep it very hot, and you need to allow it to cool very, very slowly. So I actually set up my torch and let it to preheat my material nice and hot. I didn't get it like a cherry red. I figured once I started putting some heat in there with the TIG torch, it would heat up really well. And I was actually starting to burn my knuckles through the gloves at this point because I was just sinking so much heat into this thing. But I think the way that I had it clamped and the fact that I'm using a needle scaler to peen over the welds after I'm done with them is the reason that nothing cracked. Now, as I'm welding this material and the filler rod is sticking really well to the new, regular mild steel plate. But if I let my heat get too hot, I just start to melt right through the cast iron. It's very frustrating. It's a very tricky process, but I found with patience and pulsing the pedal, I'm using my square wave TIG welder. I think it's a TIG 200. And I'm pulsing the pedal. I'm adjusting my heat on the fly. I can tell when I get too hot or too cold. And that's really the way that I found success when it comes to repairing cast iron without using silicon bronze. Now, this could have been silicon bronze brazed, but I really wanted to just try to get better at my nickel rod welding of cast iron. And these types of projects are a great learning experience for that type of project. People come to me all the time asking to repair broken cast iron things, cast iron pieces of machinery, cast iron memorabilia, whatever it may be. And my thought is the better I can get at it, the more diverse my business can be. So I try to expose myself to any additional challenge and any weird kind of sort of around the back methods that I can to learn how to do things. So again, a silicon bronze braze would have definitely been a lot easier, but this nickel braze came out great and it taught me a ton about how to nickel weld and deal with cast iron in the future. There was a couple of weird inside corners that I had to address, and I did want this to look like a factory thing. I didn't want it to look like I scabbed a piece on there, so I had to do my best to blend in those corners. The needle scaler is a really important part of this whole process because by peening the weld, you're allowing that direct energy that basically wants to shrink and crack to be dispersed and press around the material so it doesn't give it the same opportunity to crack on you, which is the problem that anyone that's welded cast iron will say is it might look good right when the weld is completed, but later on it will be cracked and you'll notice it. Now this needs to get a hole drilled in it and then be bolted to a table, so I need this to be really strong. One of the ways that you can also ensure that you don't get a crack is by allowing the material to cool slowly in a bucket of sand until it's room temperature, and I did that over here while I worked on some other things. Once it was fully cool, I could start to lay out where I was going to drill my hole and where I was going to need to grind and cut the actual foot so that it would all be nice and even and look just like it was one of the factory feet. Now, I had a feeling that the nickel rod got pretty hard from all the peening and all the heat, so I didn't want to attack this with a bandsaw and burn through a $20 blade. So I took it outside and I used an angle grinder to just start to remove material around that original shape of the foot. It's a bit of a slow process because it's 5/8 inch thick material, but once I start to shape it, it really starts to take shape and make itself look just like one of the other feet. When I was done grinding this, I did hit it with the needle scaler as well, and I was really happy with the way it came out. It does look like it's part of the original cast iron leg, and it's going to make this vise a lot more functional, being that I can now bolt it down in all 3 locations versus only 2. What's incredible to me is that anyone was ever able to break this 5/8 foot off. They must have just dropped the vise because it is about 170 pounds, but still, it would be hard to break that. Now on the inside corner, I use a Pferd Polifan curved disc, and it also just sort of helps me round out the corners. So what I like about these curved nose discs is that you can obviously use them on that special area, but then you can also just use them as a regular flap disc, which I see a lot of people doing. Now the bottom I wasn't as careful on with my weld, so there are definitely some gaps down there you can see, but it's okay. Again, I want this vise to tell a story, and I did go over and needle scale all the areas that we welded so that it would look like it, is a factory cast iron part. This, coupled with the hammered paint I'm going to use, is really going to make it hard to tell where I worked on it and where it was always fine. The next thing I needed to do was drill the hole in the foot of the base that I just welded on. And in order to do that, I went over to my welding table and I used the hole positions that are there as a guide to mark from the bottom up and understand where I wanted to drill my hole. This is a new welding table for my shop. This is a Sigmund
5x10 Imperial Plus. It's a great table. I'm going to be talking a lot about it in the future, but I put a link to it down below from Quantum Machinery in North Carolina. Now here's where I made a little mistake, cost me about 20 bucks, is I thought a regular non-carbide annular cutter would make quick work of drilling through this mixture of nickel rod and mild steel. And let me tell you, that material was so hard that it basically destroyed that annular cutter in the first couple of seconds. You can see how I started to get chips and then it just basically stopped working. But lucky for me, I had a carbide hole saw that I had bought in the kit from when I made the video about drilling holes in metal. And this was 5/8. It was exactly what I needed. And while it did take a fair bit of work to get through the 5/8 thick piece of material, when I was done, I had a really clean hole, and then I could clean up and get rid of all the debris so that I can continue to work on this. Fixing the foot was something that I was kind of dreading because I had a feeling that it had the largest potential chance to go wrong. But now that it's done and I have a fully functional 3-bolt base, I feel like I've really added a lot of value to this vise. And it's always fun to not only take on a challenge, but be successful in it. After all said and done, I had no cracks. And after paint, I've been watching it. It still looks really, really good. I used a die grinder there to just clean up the burrs inside the edge of that hole. Now you can sort of see the vise starting to come together. You can see one of the brass jaws is on, but I'm going to wind up taking it off so that I can wire wheel and prepare for paint of all these components. Now there's again some weld spatter that was all over these things. I guess these must have been in like a mechanic shop or something. And I say these things because I have 2 of these vices that I bought from the same person, and the other one's sitting on the floor waiting to be restored next. If you want to see me do something different on the second Prentice 22 restoration, leave a comment down below and let me know what you think I should do differently. Personally, I'm really excited about the brass jaws and all the other upgrades that I did to this. Now I did degrease the entire machine, both pieces, but I decided to spray it down with this self-etching primer, and you'll notice I did paint too much of the dynamic jaw and the base and a couple of things. I was kind of a little gung-ho. It was early in the morning, and I was trying to get some coats of paint on this so that it could dry properly over a couple of days. But yeah, there were a couple areas that you'll see I'm going to remove the paint from because it should never have been painted in the first place because it's a wear surface. For the actual paint, I'm using this hammered paint, for another Rust-Oleum paint. I don't recall the actual color, but I'll put a link down in the description to whatever it was. It's kind of nice. It's like a gray color, and the texture of it kind of hides some of the crimes and some of the other imperfections on the vise itself. While that paint dries, I went ahead and cleaned up the spring-locking pivot lock, which is just a little tapered pin on a spring. Cleaned that up nice, straightened it out, and then I could go ahead and take the brass jaws and clean those up using a surface conditioning belt. Now you'll see I have to take some paint off of the dynamic jaw because I did not want to paint all that. That should have been left raw metal. I should have masked it off, but it's okay. Since I didn't actually put paint on it, the primer kind of stripped off pretty easy with one of these Pferd discs. Tried to leave a nice crisp line where the jaw met the actual slide, and I think I did a pretty good job. Same thing goes for the top of this part of the vise because this is the wear surface for the swivel jaw. And last but not least, the actual swivel base plate, which I want super clean along with the bottom of this vise so that it can slide and rotate really, really cleanly. Again, this thing has been definitely abused and it's over 100 years old. So even if it hadn't been abused just from use, it would be pretty dirty and worn out. So I want to make sure all wear surfaces are perfectly clean and nice so that it works really well. You can see me starting to put the jaws on here and just get everything kind of assembled. A couple of dabs of 3-in-1 oil on the base before I put the other components in, including the spring and plunger, so that I can get the swivel lock put together. In order to finish up fixing the swivel lock, I had to just drill out this little pin and put the kind of lifter on there. It's a spring-loaded pin, and then that little lifter just keeps it up so that you can rotate it and then lock it back down into place. Now, the bolt on the bottom and the washer are kind of the perfect length for this, and they bottom out at a certain point. I just cleaned everything up and made sure that the action was really, really smooth. By lifting up that little lever, like I said, you'll be able to see that it kind of like pivots around and then pops into a specific location.
Now I added a little more 3-in-1 oil to the actual swivel jaw and the pin itself to keep everything from seizing up. And the next thing I'm going to do is just finish up the actual meatball and screw by grinding down the oil light bronze bushing I put in there and deburring the inside. I had left it a little bit long, and then I just ground it down into a nice contour so that it would look nice and smooth, but I didn't want to get any paint on it, and so I masked it off and allowed myself to grind past the paint so you'd be able to see it. Now here's a really important part of this assembly, and it is the thrust washer setup that I'm going to be doing here. So what you just saw was a thrust washer and 2 spacers, and that's on the inside and outside of the outside shelf of the dynamic jaw. Then there's a very high tension spring and a shaft collar, and basically what that does is it puts the entire system under tension against thrust washers in both directions. And what that's going to allow it to do is basically remove any friction that the screw has from binding up against the face of the jaw. So that's going to allow the handle to move incredibly smoothly and easily, and you'll be able to basically move this with just like a pinky to spin this thing in place. At this point, the vise is essentially done. You can see the way that the base lock works, and then I can start threading on the dynamic jaw. You can see how easy that handle works, even though this is a 100-year-old vise with 100-year-old threads that has clearly been used and abused. Super happy with that particular part of it and how well it came out. The thrust washers is a great way to bring new life to an old vise. And now you can see the way that swivel jaw works, and I'm going to throw a couple of examples up in the vise so you can see why you may want to try to find a swivel jaw vise. So here's a perfect example of a slightly tapered piece of steel. How would I want to grab this in the vise? If I pop out the pin, and in this case I can use the little shelves that I machined into the jaws to grab it, and that swivel jaw grabs it and engages with it perfectly. It's incredibly solid. The pin can just sort of sit back in there, and then once you put the swivel jaw back in place, the pin just falls back into place. These jaws that I made are perfect for grabbing flat stock, and they're also really good at grabbing round bar if you can get it to engage with that little V groove that I put in the horizontal and vertical position on the jaws. Overall, I'm just super happy with how this vise came out. I really like swivel jaw vices, and especially to have one this large. This is going to be a heavily used piece of equipment in my shop for years to come. I've already started using it on projects, and I'm really happy with how it turned out. Thank you so much for watching this video, and thank you to WD-40 brand for sponsoring this video. If you want to see more, follow me on Instagram, and stay tuned for more videos restoring tools and building cool stuff. Thanks.